This is lesson 6 on the fundamental counting principle. So the fundamental counting principle is a method to determine the number of ways multiple independent events can occur. So we're going to learn what this is and how to use it to answer some questions. So the first problem we're going to look at says, if you spin a spinner with 4 separate colors and flip a coin, how many different possible outcomes will there be? So these are called independent events because they are completely separate from one another. So in other words, spinning our spinner is not going to affect the answer that we get when we flip the coin. To find out all the different possible outcomes there would be, instead of having to list our sample space like what we were practicing in lesson 5, we can actually use another method, but to get there, we're going to start by listing our sample space like what we have practiced. So I'm actually going to have you do this first as a little recall into what we did in our last lesson. So you're going to list the sample space of spinning the spinner and flipping the coin and the total amount of outcomes. So I'm going to have you pause the video, list that out on your own. When you're all set, unpause the video and just make sure you've got the right answer. Okay, so our sample space we could either have yellow and flip heads, red and flip heads, blue and flip heads, and green and flip heads. Now we could do all those same colors, but instead of heads, get tails. And this is just, again, what we talked about in the last lesson. In total, there are 8 outcomes. And listing 8 of them wasn't too bad. But when we get to a value that's got a lot more outcomes than that, there is an easier way, and that's called the fundamental counting principle. So in order to do that, we need to know how many total outcomes there are on the spinner. So if I take a look at my spinner, there are 1, 2, 3, 4 total outcomes. How many outcomes are there on the coin? I know that there are 2 total outcomes on the coin. So the fundamental counting principle tells me that I can take the outcomes of my 2 independent events and multiply them together. So 4 times 2 to get my total amount of outcomes. And that's all we have to do. So let's go to the next page and practice this. So it says, find the total number of outcomes when a coin is tossed and a number cube is rolled. So we need the total outcomes for the coin and the cube. In a coin, we've got heads or tails, so 2 outcomes. A cube, 1, 2, 3, 4, 5, or 6, so total of 6, so 2 times 6, 12. Find the total number of outcomes for rolling a number cube and choosing a letter from the word numbers. Then find the probability of rolling a 6 and choosing an M. So 2 different steps here. First step, using our fundamental counting principle to find the total number of outcomes. So I have my cube and the letters in my word. So on my number cube, there are 6 options. In the word, I have 1, 2, 3, 4, 5, 6, 7 letters to pick from. So 6 times 7, my total would be 42 outcomes. So that helps me too to answer my question on the probability. So the probability of choosing an M and rolling a 6. Well, when we've taken a look at all of our sample spaces, so if I just flip back to what these look like, it's only asking me about one thing. So rolling a 6 and selecting an M. So that would only give me one of the options if I was to list out my entire sample space, which I don't have to do. So the probability of 6 and an M, that's one option out of all my 42 options. Okay, next page. It says, how many possible combinations of party decorations can you make from the set of items below? So we've got a banner, balloon, and ribbon. So same thing, I just have 3 different independent events, so I'd still multiply all 3 of them. So I've got 2 options for the banner, 3 options for the balloon, and 3 options for the ribbon. So I just multiply 2 times 3 times 3, 9 times 2, which is 18. So 18 total outcomes. Then from there, I could answer a bunch of different questions about probabilities. Number 4, the school cafeteria offers a choice of 2 main courses, grilled cheese sandwiches or soup, and 5 desserts, Jell-O, pudding, fruit cup sundaes, or granola bars. How many different lunches could you have? So in total, they just want us to find out how many outcomes. So I'm going to have you find that. So please pause the video, unpause, and check your work. So we've got our main course times our dessert. So 2 times 5. So a total of 10 different lunches you could make. All right, that's all for this lesson. Good luck on the homework, and just remember on the homework you're using the fundamental counting principle to find the total number of outcomes, and then don't forget if it's asking you a follow-up question, make sure you answer the follow-up question.